and Assalamualaikum. So we are from Group 3, Section 9, and I am Muhammad Zikri bin Hamid, and I will explain about the Activity 1, which are the electrical power measurement in a DC circuits. So we will need to design the circuits like the figure 6.2. So I am using the Proteus software. So here are the circuits that I designed referring for the figure 6.2. So here we have the DC source, which are the BS with 60 volts, and then we have the voltmeter DC and the DC ammeter. We have the load RL, and also we have the watt meter here. So we have to simulate the circuit based on the table here. So we need to for the resistance RL 100, 200, 300, 400, and 500. So we will start with the 100 ohm resistor RL. So here we got the DC voltmeter 59.9, which are almost the same with the output voltage of the BS. As for the DC ammeter, we got 0.6 ampere, and for the watt, we got 35.9 watts. So these parameters are for resistor of 100. So next, we will change the value for the resistor. So we take 200. And right now the meter shows the value for the resistor 200. So as for the voltmeter we have 60 volts. For the ammeter we got 0.3 amp, and as for the wattmeter we got 18 watt. So here are the result for the full simulations. So we got the result for the resistance 100, 200, 300, 400, and 500. So in the simulation, we got the voltage, we got the current, and we got the power. As for the calculated power and the calculated power with error, we will need to calculate it using the formula given. So for the calculated power, we use the simulated current I, time with simulated voltage, and we will get the answer for each resistor value. As for the calculated power with 3% error, we will use this formula, which are 0.97 times with P calculated, which are the above, using the above calculated value, and we will insert it for each of the resistor value. So here are the result for the P calculated with 3% error. So in the table, we got all the value for each of the resistance, and here are the result for it. So that's all for activity 1. Thank you. So now we will continue with activity 2, which are the electrical power measurement in an AC circuit with resistive loads. So we are required to design the circuit based on the figure 6.3. So we'll based on the AC circuits. So here are the circuit that we design in the Proteus software. So in the circuit, we have the AC source, which are the VS, with 100 volts and 50 hertz of frequency. Next, we have the AC voltmeter, the wattmeter, and also the resistance RL. So the resistance value is same with the previous activity. So we got 100, 200, 300, 400, and 500 of resistance. So first we will simulate for the 100 ohm value. So now there is a value in the meter. So the value in the AC voltmeter actually is the value for the VRMS. So in order for us to achieve the V peaks, we need to times the VRMS with set 2, which are 1.414. So 70.7, if we time with 1.414, we will get 99.97, which are almost the same with the volt value at the AC source. So it will be equivalent to the AC source volts value. So next we have the 50 watt for the voltmeter. So it is the simulated real power P in watts. So next we will simulate for 200 value of ohm. So we can see here that the value for the AC voltmeter are same, but the value for the wattmeter is different. So here the result for the value for 200 ohm resistance. So here are the full result for the activity 2. So we got the simulated peak voltage and the simulated real power from the simulation. And as for the calculated real power, we will need to calculate it with the formula Vrms square divided by RL. So the Vrms that we got in the simulation circuit, we are 70.7. We will use in the calculation, and we will divide with the each of respective resistance. So using the formula, we'll get the P real, the real power of for calculators, and here are the full result for this activity. So that's all for activity 2. Thank you.
Assalamualaikum, I am Muhammad Afif bin Ahad Nulisam. My metric number is AE190052 and I will explain about activity 3. Electrical power measurement in AC circuit with capacitive load. So for the first step is we need to create a connection shown in figure 6.4 in the simulation software. So this is the figure 6.4, the circuit connection for power measurement in AC circuit with capacitive load. So for the software, we use the Proteus software. So for the next step is we have to set the supply to 100 volt amplitude and the frequency is 50 Hz. And then we have to calculate the value of impedance using this formula. So for the next step is we have to simulate the circuit and measure the apparent power and real power. So for example, I will use 2 microfarad capacitor and 100 load. After clicking run, we can see that the apparent power and the real power is both 50, and then we have to table we have to record the data on the table here. From the table above, we need to calculate the power factor using this formula. Real power divided by apparent power, we get the power factor. So for this activity, all of the power factor is 1. That's all for activity 3.
Assalamualaikum warahmatullahi wabarakatuh and hello. My name is Muhammad Rafiz Bezulkifli with metric ID AE190016. So next I will proceed about lab 6 in activity 4. So in this activity 4, we need to calculate the apparent power, real power, and power factor. So firstly, we need to set the AC voltage supply to 100 V peak and 50 Hertz. So here we already set the value. Then we use the voltmeter to calculate the volt, the wattmeter, and the power factor meter. So this is the resistor with 100 value ohm. For next is the inductor with 0.002 Henry. There are 5 different number of inductance that used in this experiment. So we firstly use for this 0.002 Henry. So we run the simulation. Wait a few seconds until the calculation stop. So this is the final value for this load. We get 70.7 voltage. For watt, we get 50, and power and apparent power we get 50. So this is the result that we get from all the impedance that we already calculate. A bit different for the last load, which is used 0.01 Henry, which is 49.9, which power factor is this calculation and get 1.002 is a bit different. So that's all for activity number 4. Thank you.